I am Group Captain C.S. Chandel, Secretary, Air Force Association. On behalf of Veteran Air Chief Marshal R.K.S. Bhadoria, PVSM, AVSM, VM, President, Air Force Association, I take the honor to welcome all the invitees to the 38th edition of Air Chief Marshal P.C. LAL Memorial Lecture. You are all aware that the Air Force song has been a source of great inspiration for air warriors and air veterans as well. All the Air Force functions also commence with the singing of Air Force song. We at AFA also follow the same tradition. The lyrics of the song will be projected on the screen. I request all of you to kindly sing along aloud. May I request all of you to kindly rise for the Air Force song. जब सबको सुख बांटे एक समान, नीलवर्णी वालों का दल बढ़ता आगे सीना तान, वायुसेना की ये शान, पीछे हो या करे कमान, बन खतरा कोई आए पर जब फैलाओ पर कर प्रहार लौटाओ घर शत शत तुमको नमन देश पुकारे जब सबको दुख सुख बांटे समान नीलवर्णी वालों का दल बढ़ता आगे सीना वायुसेना की ये पीछे हो या करे कमान, पर खतरा कोई आए अगर छाए लब पर काल समान। Please be seated. The proceedings of the evening will be conducted. The proceedings of the evening will be conducted as shown on the screen. We'll have welcome address by the President, Air Force Association, then lecture by SHRI SOMANATH S, today's esteemed guest speaker. Vote of thanks by Senior Vice President, Air Force Association, and lastly we'll have tea in the foyer outside. In the recent years, India has made huge strides in space technology. Hence, it was most appropriate to invite the highest authority on the subject to address this august gathering. SHRI SOMANATH S is a distinguished scientist who is holding 3 important appointments, vice Secretary, Department of Space, Chairman, Space Commission, and Chairman, ISRO. He has kindly consented to share his views on the developments in the field of space program with special emphasis on their exploitation by IAF. The latest information on the progress and achievements will definitely enlighten all of us and make us proud. May I now request Veteran Air Chief Marshal R.K.S. Bhadoria, sir, to deliver the welcome address and introduce our esteemed guest speaker to the audience. Sir.
At the outset, very warm welcome to Mr. Somanath, Chairman of Space Commission and Chairman ISRO, for agreeing to speak to us on this very important subject so dear to us. Thank you for being here. Air Chief Marshal Chaudhary, our Chief of Air Staff, former Air Chiefs, ladies, serving officers, senior officers, veterans, distinguished guests, ladies and gentlemen. We annually have this event, is Air Chief Marshal P.C. Lal Memorial Lecture. And in this series, this is the 38th lecture. We are really honored and privileged today that Air Chief Lal's son, Mr. Robe Lal, is with us, and Mrs. Lal. A very warm welcome to you, and thank you for being here. This memorial lecture is important because it carries on with the legacy that Air Chief Lal left behind, and the fundamentals that he put in place for the Air Force, the aviation industry as such, is still showing results. Air Chief Marshal P.C. Lal has been one of our most illustrious chiefs, and he scripted the most glorious chapter in the history of Indian Air Force in the 1971 war. And that chapter, the way the operations were conducted, the way air power was utilized, that is the final proof of what his professional excellence was, what his vision was, what his philosophy and strategy of air power, and actually getting down to implement it and show the result. And it was not only in the field of air power that he was looked up upon. The national leadership at that time gave him the responsibility to head the Indian Airlines, the Air India, and the Hindustan Aeronauticals Limited. So the entire military aviation, the entire air power, the entire civil aviation, the entire aviation industry, he was at the helm at that time. And a lot of visionary action taken and things put in place are, like I said, still showing results. In this series, we make our best attempt to get leading lights from the country to speak to us on subjects which are connected with national security and areas of interest that we have. And from that perspective, I think today's talk on space is very apt. It is something that has been dear to all of us in Blues. It is also something that has been a case of so close and yet so far. We wanted to have more control and more say in it, and it is still a work in progress. So it is an area that is really, really important for Air Force. It is an area that is important to everyone today, and everyone wants it. So, speaking on the latest on the subject, in this scenario, where from security perspective, it is really evolving fast, and space related assets and capabilities and developments and the way technology is moving will not only define how the next war is conducted, it will largely dictate the control and exploitation of the space would largely dictate who wins the conflict. It is a very rapidly changing scenario from security point of view and very important. And equally important is the environment in our country from space-related issues. ISRO has been on the forefront of how things should be done right in the space sector for the constraints that they faced and the budget that they had. They really demonstrated to the whole world what they can achieve. They have a wonderful history. And in the current scenario, they are evolving fast and setting new standards as to the direction that space needs to take, the new policies of the government, opening of the space sector to the private sector. It is a whole new game and a whole new challenge for the entire industry, the entire strategic community, the entire defense community who are going to employ it, exploit it. And from that perspective, I think we couldn't have got anybody better than Mr. Somnath, who's with us today. He is the chairman, like I said, of Space Commission and ISRO. He doesn't need much introduction, but just to kind of briefly summarize his, life story in terms of aviation and space. He did his BTech from Kerala. He's a master's from IISc. He joined ISRO and never looked back, continued to grow and demonstrate his immense skill and knowledge. He was involved in many of the critical projects and successful projects that we see today, be it PSLV, be it GSLV, be it cryogenic engines. Finally, when he took over as director of VSSC, really path-breaking effort in GSLVs and your Chandrayaan happened on his watch. Of course, as chairman ISRO now, he is really scripting new chapters on how to involve the private sector. This opening up of space at the pace and at the depth which is happening towards the private sector is absolutely unprecedented. And I think you are demonstrating how the industrial capability of the country should be utilized to achieve our ends. And our normal industry in defense and aerospace should learn a lot of lessons from you. So without any further ado and without taking much of your time, I think we all want to listen to him on matters of space and see where we are today and where we are headed. And I'm sure we'll be more educated at the end of it. Mr. Somnath, please. Thank you.
Okay. So let me begin. So good evening, all of you. It's really an honor to be here in the midst of our Chief of Air Staff, as well as the veteran chiefs, as well as air veterans and also serving officers. It's really an honor to be part of this legacy of Air Marshal PC LAL Memorial Lecture Series, this being the 38th one. So let me first of all thank all of you for considering me as an eligible choice to speak to you today. And it's really a great honor to speak to all of you who have done great contribution to this nation. I thought that I should speak on the space sector and it connect with the strategic sectors. This is something that has been evolving in the recent times. Of course, all of you know that the space has been an independent domain where we operate beyond the air available, the atmosphere, with the Kalman line and above is the domain of space, where it used to be much below used to be that of IF's domain. So now the thin line that's separating these two domains are actually breaking. And the Kalman line is actually pushed upward, I believe. I don't know, it's pushed downward. I still do not know. But then the interaction between space sector as well as the need of its utility in various sectors is actually increasing greatly, and that will be definitely been able to be showcased today in my talk. And of course, I have gone through the life and contribution of Air Chief Marshal PC LAL, and let me pay my own homage on the occasion of this talk and dedicate this talk in his memory. Also, my greetings to his family and son, wife and son, for being in this talk series as well. So let me begin on this talk. I should also speak about what Air Marshal Bahadur has just spoke about, the changes that is happening in the space sector. I call it not Indian Space Research Organization. I would like to call it National Space Enterprise. So it's no longer an organization that is going to drive the space sector. It is going to be the nation where we will have various actors, which are institutional actors, the department, the regulators, as well as private industry coming together to create the bigger picture of space. And we thought that this is important at this moment to create a larger share of the space economy in this, bringing in various actors who will really contribute to building up the economy of scale, which is actually lacking. You know, all of you know that the space sector is actually being invested only by the government through Department of Space, which continue to remain at certain level over last many years. And if you continue like that, it will continue like that only. It will not never grow to a scale where it will actually bring benefits in various sectors, including strategic sectors. This has been well understood, and we created new institutional mechanisms like the NSIL being empowered in space as a regulator and promoter to bring private ecosystem. Industry and startups are being engaged more in space sector, and we hope that we will have a good share of the global space economy in the future. So this is something which is so dear to us, and we will work on it while we work on technologies needed for the nation. And on another domain is called space infrastructure. Space infrastructure is nothing but the spacecrafts and ultimate delivering products for utilization. Here again we see a transition which is very evident in the picture. You can look at the colors. The orange color indicates the industry which is started as a nascent industry is actually going bigger and bigger towards the year goes. So we envision that much of the work which is done in the spacecraft building, operations, delivery of these products and services will actually move from the governmental ecosystem to a private ecosystem. And ISRO as an organization which will do the research and development will be focusing on niche areas where there are domains which need to work on, essential domains where research and technology development should happen, and not into every domain that can be done through industry. And this is the change that we would like to bring about in the sectors. And we said that there is a huge business opportunity with certain moderate risks that are important. But the domain of space transportation, which is essentially building rockets and launching, it won't be the case, you know, like what we saw in the satellite sector and other sectors. There, of course, the role of the industry has been a supplier-based area, and they are slowly expanding to a level that will moderate to a scale. Maybe 50% of the overall work of the launch vehicle sector could be done by industry. But development of key core strategic capability of having rockets of our own, building core technologies of our own will continue to remain with a government-funded scheme, which will be piloted by Department of Space and ISRO. So this is what I would like to initially say about the sector. But the bigger role where the private industry will be able to play is in this sector, the application sector, which is very, very important, where private people have lesser risks of failure. The technology complexity is very, very small. The scale of economy is big. The return of investment is very high. So, and the overall economy is bigger in application sector. And we are inviting many companies to come and work in this sector and deliver ultimate results of whatever we are doing through rockets and satellites to the community, which includes the strategic community. We will discuss that a little later. And we would like to enable this transition to happen with the private industries in due course of time. And many small companies are coming up to do these services. Now let me look at the strategic perspective of what the space sector is. So we will look at, there are certain capabilities that we need to develop over a period of time, which we have been developing little bit, but that's not enough. We will look at it a little deeper. One of them is imagery intelligence, which is very important for various activities. We also need to have secure communication, navigation, and also communication in difficult terrains. And this is very important that we need to have this capability. We should also have very important capability to have our own rockets being built in India without any technology denials, and also capable to launch whatever satellite that we launch from our own land. This is a very strategic capability. Everybody is not having it. Most of the nations are not having this capability. There are only limited capability. And this we have developed over the last so many years, 60 plus years, and we need to nurture it, develop it, expand it. It's very, very core competence. We also have to have reconnaissance applications, space situational awareness. We will discuss it deeply a little later. Also the intelligence, surveillance and reconnaissance capability through the space, and also capability of orbital re-entry vehicles and other similar activities which need to supplement this. We would like to bring about a strategic space group creation, ultimately looking at space and air together. In the space transportation, which is essentially the rocket design building, I think we have showcased the world that it is possible for India to build any rocket that we want to build. I think there is no doubt about it today in anybody's mind. Where you want to build a solid-based rocket or a liquid-based rocket or a cryogenic-based rocket, we can build it. And it can be built very frugally. The investment that we make for building a new rocket is one of the lowest ever in the world. For example, when we built the GSLV Mark III LVM3, the expenditure was hardly 2,500 crores. The entire development cost, including infrastructure cost, the hardware cost, etc., and developing it and launching it, which is maybe 10 times lower than that could be done elsewhere in the world. But to retain this capability and then build future rockets, we need to continuously invest certain amount of money and investment, also create engines which are very crucial for the future technology. So here we need to create investments and push this idea to have the strategic edge over others, which is very, very important. We also have to have an idea where we need to really remain looking at the nation as well as our frontiers, which are very close to the boundaries of our country, or we need to have capability globally. This is something that we need to take a view. Whether we need to have global communication capability, which is not there today. We cannot communicate with any of our devices and instruments globally over secured platforms, which is still not existing. We do not have global observation capability, though we have satellites. If you want to take imagery of another location, strategic location, and give information, really we don't have real-time capability. It can come maybe a few days later, but we really do not have. We also don't have global navigation capability, especially in secured, precise timing and position services, which is also a strategic capability. So let us look at these three capabilities and whether we need to develop it over a period of time to make our nation stronger. So this is specifically, these capabilities will come only through space-based capability built up over a period of time. If you look at the advantage we have compared to many other nations is that we have a very reliable space capability today. We know how to build satellites, how to build rockets. That capability exists in this country. And this is not a small capability. And we can also build systems on demand if the nation really needs it. So some of the elements that build up this global capability development over a period of time require certain investment and certain research and development, which I will detail it later. One of the important capability, I believe, is to have reusability, especially with the winged rockets. Though we have been working on it over the last 20 years plus, we have not made big headways. One of the important results that you all know, you have just seen the video of the RLV landing is the first of the results that we have showcased, that it is possible for us to have autonomous vehicles that will go to space, spend some time there and bring back. We also have to create air-breathing similar capability of rockets and spacecraft that will go to space and come back. Of course, world over this work is happening. Even if you look at US and China, there is a continued effort to create winged reusable rockets, even after shuttle has retired. The shuttle is no longer flying, but there are other series of rockets which continuously go up and come back on a regular basis, and also in China. So this work we need to continue and create that capability over a period of time. And possibly you would have seen this video of our RLV landing. This is a scale model of the reusable aircraft. We did it with the help of IAF and many other agencies to have this helicopter flight of this to a certain height, drop it and have the autonomous landing. And this test will continue for some more time until we create reasonable amount of confidence on this. And next step is to take it to the orbit through a craft like this. We have already done the full engineering of this craft, which is an orbital reusable vehicle. This rocket can go to the space. It will spend time there. We can have a 300 to 400 kilogram payload capability, autonomous mission management of various kinds, and then come back and land in an airstrip where we will be able to do certain amount of activity through this, which is a scientific activity or a strategic activity, whichever is that we want to do. So I want to tell you this currently, this is an approved program which we are running, and then making sure that in another 2 years plus, we should be able to make this mission possible before we get into various other development. But this is a very involved project, as all of you know, that this has a very orbital re-entry technology involved, high temperature based materials, special materials, controls, like what the space shuttle developers would have ever felt it. So this is one of the challenging missions that we are currently running. Yet another important work is in terms of air-breathing capability. Possibly all of you are aware of the scramjets, and the scramjets, how it's so important to have propulsion capability in hypersonic regime, especially Mach 6 and beyond. This we have done, this have been working with various other nations in this world, and a lot of collaboration. We developed certain capability. We also did a mission some time back using our sounding rockets to initiate a scramjet test with the hydrogen fuel. Now we are developing and designing a rocket which will fly with a kerosene-based scramjet design, and ultimately build a craft which will fly for long duration missions. Typically something like 400 to 800 kilometer range it will have. And it will cover this much of time in certain matters of seconds with the speed. So here we have to use a rocket to take it up to that altitude, then come back and reach the Mach 6 condition and then continue in the scramjet mode autonomously until we demonstrate the entire technology. So all these technology elements are now under testing. We have our scramjet engine has been realized, and it is now under testing in a ground test mode, connected mode testing. We call it vitiated air testing, where we create the air of that type of temperature, stagnation conditions of the air at the admit of the engine, and this engine is under testing. First of our testing have been completed, and we hope to put it in our belly of the engine and then do one initial test soon. So ultimately our goal is to create this capability for a full-fledged vehicle, which is also an approved program currently running in Department of Space. So the vehicle will look like this, and the entire engineering of it has been now completed, all composites, special materials and things like that, with a very fine atomization of engine within the scramjet engine. Of course, all of you know scramjet engine is an engine which doesn't have any moving part, and it generates the forward thrust purely by the compression that it achieves through the scramjet action at hypersonic speeds. Yet another capability is the on-demand launch capability of satellites when we want it. And this has been targeted specifically to develop a rocket called Small Satellite Launch Vehicle, which we developed last few years. And this project started just 4 years back. And our first mission was a failure, and the second mission was successful now. We are going to continue this mission for launching small satellites, microsatellites soon. And I want to tell you, even before it has become operational, I have an order book full for 15 launches of this rocket, which is really good. And we would like to transfer this rocket to an industry to produce and launch on a regular basis, and possibly from a mobile launcher. So this is the situation now. And once you have a solid-based rocket launcher with a very little bit of liquid upper stage, it becomes an on-demand launcher, capable of launching up to 500 kilogram satellites to low Earth orbits for specific missions. So we look at it as an opportunity for on-demand launches, and also launching large constellation of small satellites which can do functions like surveillance, as well as at low altitude observations and the times of need. So we look at it as a strategic capability. Equally important is to have a commercial capability in this mission. So we built a very low-cost building concept, and I can tell you this rocket can be manufactured by people in the industry who are second-tier, third-tier industry. So we designed it such a way that we don't need very exotic machines or sophisticated machines to manufacture the parts of it. And now I can tell you this rocket is made at almost 1/8 the cost of a PSLV. So you will really wonder how we are able to do this, even to achieve 50% of the payload capability of PSLV at almost 1/8 the cost of PSLV. So this is what we did, and we would like to create a battery of these rockets for on-demand capability. You may wonder that whether human spaceflight, Gaganyaan, is really a strategic capability or not. So let us look at from this front whether when we fly humans to space, how it adds value to the technology development that we are doing in space sector. We believe it is. Humans flying on a regular basis to space, doing certain activities in space, coming back to Earth and safely come back, and do it on a sustained basis is actually a strategic edge. And you can even look at the work done by Russia and the US over the last so many years. They continue this effort, and you won't really know what is the tangible benefit that is coming out of hundreds of people going to space and coming back over a period of time. What they are doing with this. And I can tell you the real crux of it is in terms of the technology development. The technology development in various fields, which includes materials development, manufacturing development, high-quality processor development, specific biomaterials development, and all this adds to the industry, drugs and other pharmaceutical development, and all this add value ultimately to the technology strength of the nation. So they have understood very clearly that continued presence of human beings in space is a strategic asset for any nation. Of course, going to Moon and Mars and creating colonies is definitely a very good thing to speak to young people. But then ultimately a nation looks at how much you should invest in space and what value you create out of it. I think this need to be debated, discussed quite a bit, so I won't dwell on it. I will only say that today we are on the Gaganyaan program. And we would like to make sure that we succeed in this over a period of time, and currently we are progressing very well. Let me go through a little bit on the Gaganyaan program for your information. Again, the rocket comes into as a big element in the Gaganyaan program. The most important part is the rocket must be very reliable. So we have started a program called Human Rating of the Rocket, called LVM-3 rocket. And this rocket, I can tell you, today it has been reasonably, completely human rated by operating its various capabilities, building higher reliabilities in these engines, and entire test program of the engine has been now completed. And we also developed a new rocket called test vehicle. You can look at this rocket here, and in this we will carry the crew module where the crew will ultimately travel. We'll take it to certain altitudes in the flight regime. The first mission is going to happen in August. In the first mission, we'll take the crew module to a height of almost 15 kilometers up. We'll create an abort scenario of failure, then bring the crew back using the parachute system and splash land in the sea and recover it. So we would like to see how this whole process of detecting a failure on board is found out, how we can recover the crew safely, which is very essential part of the Gaganyaan program. Ultimately, crew loss is something that you cannot tolerate. Either they should go to orbit, or in case of an anomaly, they should be safely recovered. So these are the two conditions that are acceptable to us. So we are developing this system to make sure that the Gaganyaan program go through the testing of failure scenarios first before we actually look at success. And once we develop this vehicle, we find that it's a huge potential in the future. Once we develop the test vehicle, it can demonstrate the vertical landing technologies, which is important for reusability. We also want to integrate it for air-breathing engine deployment. We also want to use it for a space tourism, which is another commercial exploitation of this capability. So we designed this vehicle such a way that it can feed to multiple possibilities of strategic intent, low-cost rocket development, as well as space commerce. So this is an idea that we mooted some time back, and we are slowly able to progress in this direction. I want to tell you the crux of the space technology development is the Atmanirbharta. I think this cannot be forgotten. When we started the space program, we were dependent on the entire world in terms of the materials, specific design, knowledge, etc. And most of the rocket parts, for example, I started in PSLE as a young engineer. When I started, almost 50% of the rocket components were imported, including aluminum, steel, the special alloys which we use for the manufacturing of the parts, most of the electronic parts, standard products including nuts, bolts, and fasteners. All of them were imported. And today I can tell you, after the last 30, 40 years of work, 95% of the rocket parts are sourced from Indian companies today. They are manufactured here. They are either processed here, including metallurgical knowledge, manufacturing knowledge, everything exists here. And that 5% is nothing but high-end processors or computer chips or some memories, which is not manufactured in India. Other than that, everything comes from Indian companies, and we are so happy about it. So we looked at the whole indigenization process as one of the important elements. You will wonder, the computer that flies in the rocket is actually Indian design processor, even including the chip design, the compiler design, everything is done by our own people, and it's not known to anybody else. The entire material that we use in this actually manufactured in some companies and melted and alloyed here and processed and forged and made, everything in India. And all the manufacturing process are happening in either in HAL or related MSMEs and industries. So even the batteries that we use in the rocket are made within our own facilities. Now only we recently transferred to industries to produce our batteries. So you can understand that all the complex elements that we use in rockets are made in India, but there is still a gap, especially in the area of satellites. Almost 40%, 50% items still come from external sources, and they are mostly electronics items. So we looked at the indigenization process in a big deal over the last many years. 1970, we started the program of indigenizing aluminum, titanium, maraging steels. And you may wonder, the entire titanium required for our space program is actually made from our own plants, and it's made in Chavara. We recover the titanium, we go to Midhani, we melt it and make the billets. Then we go to Bayforge at Chennai and forge it, and then we get all the forgings that we may build all our materials. So similarly, the composites, all the carbon composite, silica composite that we use in nozzles, thermal, everything is made in Indian companies today. And we also started high super alloys like nickel alloys, copper alloys, niobium and hafnium production plants, all these established in the last many years to create this capability. Today we are looking at advanced materials like the silicon carbide, 3D printed material, high temperature materials. We have slowly developed over the period, developed carbon composites, silicon-based materials, etc. for high temperature applications. So it's a long journey of developing materials and capabilities. Similarly, we started on propulsion. We started on new propulsion like the chemical-free, corrosion-free, atmospheric green propellants, and also hybrid propulsion. So all these have been new developments in the past. Similarly, look at the composites. I think all of you Air Force people are so familiar with the composites. I don't know, most of the airframe has now the large segment of composites. So is a rocket. Over the last so many years, we also moved from aluminum-based structures of hardwares to composite hardwares. And introduction of composite into our rocket and satellite part is very, very high. And here again, a lot of improvement in technology over the years happened, and this is something that we worked on last many years to create indigenous capability within country to build composite products. Electronics is very, very important, and all of you know that the electronics is the core of the nation's technological strength. And unless you have that capability within the nation, many of the advanced design that we want to do can never be done. We need to buy it from nations which you prevent it. So all the chips that we get are actually outdated chips from Western countries. So it becomes important for us to build it within India. And you know that gap area of having indigenous foundries to build electronic products is still a dream. And the initiative by the government is something which you should hail for investing more in electronics production. But I can tell you very, very critical components we were able to build it in India using the foundries that we have with the very limited capability that we have. Now we talk about the communication side. We see that the entire communication infrastructure for today is actually based on what our ISRO has developed, that you are already aware. Our television broadcasting, VSAT connectivity, the high throughput link, all are through ISRO satellites or the private satellites we lease from other agencies. And we serve all the SATCOM users, including operators. And we look at a transition in this. This transition is what I would like to see. And no longer this will be the model. And ISRO will not be building and launching communication satellites in the future the manner which we built earlier. And this is something that is changing now. But before that, we get into that business model of it, let me look at the challenges in the communication. One of the important issues today is to create a deep space optical communication capability. You know, the RF communication system today has a limitation of the bandwidth, the amount of data that you can transmit over radio frequency regime is actually limited. But once you go to optical communication, you can actually transmit terabits of data at very high speeds. So we are looking at how to develop this optical communication capability. We launched a payload recently in our satellite, and we are testing it now. And we hope that soon we will be able to come out with an optical communication capability from space, which is going to be a very strategic capability to communicate hope over the world and then communicate with anywhere at very high speeds. Very important capability is a quantum key distribution capability. We need a very secured communication networks. And this terrestrially, if you are to achieve a secured communication network, it is possible only by a quantum key distribution capability. We need to have a space-based satellite which will send the quantum keys to the source and the destination so that it can be decrypted without security loss. And we are working on this capability. Our payload is just ready for testing. Similarly, we have a satellite-based automatic identification capability development and also communication with remote areas. Also want to tell you that observation, satellite-based observation of Earth is very important. And today we have 24 satellites which is looking at Earth. I can tell you 24 is not a big number. 24 is actually a small number. It used to be a big number in the past, but today looking at the type of satellites which are coming in globally in terms of observation, we realize that 24 is such a small number. And we need to very, very drastically improve this number to 240. 10 times increase is required in the coming days. If you really want to have observation of any place on Earth, or even India and our neighbors with reasonable repetitivity and high reliability. And this is something which we need to develop, which I'll quickly describe. We also work on scientific missions. I think you know that while we look on this operational capability, it is important that we work on scientific missions like the Chandrayaan, the AstroSat, Mars orbital mission, and Chandrayaan 3 and Auditorium 1 are coming to be launched. For your information, possibly you know that Chandrayaan-3 is just ready for launch. The satellite is already integrated with is getting integrated with the rocket in another few days. And we are looking for a launch in July middle for soft landing on the moon. Same is the case with the Aditya L1, which is an interesting mission to study the sun. Look very close to the sun, not really very close to the sun. It is closer to the sun than Earth. So we go to a Lagrangian point called L1, which is 3 times the distance of the moon from Earth. And we go there and stay stationary and look at the sun and study. Why? Because sun has so much influence on our weather and climate and electromagnetic interference of the Earth atmosphere around us. So we need to study sun more carefully. Possibly you know the AstroSat, possibly you may not be knowing in depth. AstroSat is one of the best instrument observatory that we have launched to study the universe. We looked at black holes, we look at supernova explosion, we look at the creation of the stars, explosion of stars. Many of the black holes identification has actually happened from AstroSat, and some of the exosolar planet discovery also happened through AstroSat. It's very scientifically one of the best instrument that we launched with at a substantially low cost. Probably you would have all read about Mars orbiter mission Chandrayaan, but never heard much about AstroSat, about its accomplishment. But I will rate AstroSat as one of the greatest scientific satellite we could ever build and launch in India. We look at various new technologies in satellites from strategic aspect. One is we are building a technology development satellite, TDS-01, which will be an all-electric satellite. We will not use chemical propulsion, we use an electric propulsion. Basically, this brings down the mass of the satellite substantially. And we also want to demonstrate our own design of the traveling wave to amplifier, TWTA, which is an essential building block of any communication satellite. Today, you know, TWTAs are manufactured only by 2 or 3 people across the globe. And we have to wait in the queue to get it if you want to build a satellite. It takes typically 2 years to get one order realized for building satellites. This becomes a bottleneck. So we took this action to design and develop our own TWTAs. And I can tell you, the world-class TWTA has already been designed and developed. We have tested it, and we are going to fly in this satellite by next year beginning. And with that, we will be able to remove the dependency of TWTAs for any global suppliers. We are also building software-defined satellites. Software-defined satellites are the one where you can reconfigure a satellite from its original intent of different type of communication networks, beam formation, pattern change, frequency switching, all these are possible through software means. And we are building one of them to demonstrate the technology. We are also building the quantum communication capability soon, and we have already demonstrated it through free space, this quantum communication capability in one of our ISRO centers. Another important capability development for strategic area is the expansion of the surveillance networks around the country, especially the sea-based networks. So we looked at how we can detect ships, aircrafts in and around our borders. So this becomes one of the important topics, and recently we did a payload. This launching was in one of our SSLV second launch. We launched a ADSB detection, that is aircraft detection payload we launched. And the result was exceedingly good. With a small payload, we could see the entire aircraft flight very accurately. And now we went to Airport Authority of India immediately and showcased them this, and they were so happy. And they wanted us to launch now a constellation of satellites to observe the entire ocean-based aircraft observation in and around the country. So this becomes one of the important inputs for them to navigate the aircrafts all around the nation. So we are building a constellation for them. So we are in discussion with the Airport Authority of India and build this constellation for them to look at aircrafts. And I believe this can actually serve Air Force as well so much, especially in communicating. And we are not only going to build it for identifying an aircraft, we are looking at how we can do voice communication with aircrafts, which is in motion. So with the channels available with this, we find that it is possible to communicate in two-way communication between any aircraft anywhere in and around the airspace of India. So this gives you an excellent capability using a satellite constellation. We are also looking at how we can have the ship identification capability also built into the satellite so that we can do multiple roles using the satellite. This is another strategic capability we are building. We are also looking at how to build a high resolution, big satellite, which will look at India as a whole. Say today, you know, satellite, when you move around, it looks at one place and comes back in another orbit, and it will take maybe 1 hour later only it will come back to the same location. But think of a satellite which is huge like this. it looks at the entire India, and like a camera, it goes on taking the pictures at very high resolution, typically 15 meters, 20 meters resolution. As a video, if it is capable of taking it, then you see the whole of the nation at a very high resolution. And after identifying a specific area, you can move to a very high resolution satellite, can be positioned to look at it more closer. So this satellite is currently under design, and we would like to offer it to the strategic community as an observational platform for the entire country. We are also working in robotics quite a bit, and we would like to see how we can develop this capability. One of the important missions that is going to happen is to create a grabber. Go to space, go and grab another satellite and bring it back. This is for repair purpose, it is for refueling purpose, it is for docking purpose, building large structures, etc. But it also has other intent of strategic intent in going to do certain things in space. So we are currently working on creating space robotics capable of doing this type of work, going proximity studies, capturing something, doing a refueling of purpose, etc. And we are going to do it in a very low cost. You will wonder the type of cost we will incur is exceedingly less, and using an existing platform of PSLV, we should be able to do this. Another big challenge for our people is the debris in space. Possibly you know that the debris in space is increasing. Currently there are almost 14,000 satellites in orbit, out of which 80% are not working. I think this is a very important news for you. And very low number of satellites are only functioning, and many of them are dead and they are rotating around it. And the most important part is there are 30 million fragments of satellites and parts, which is almost 0.1 centimeter to 1 centimeter size, which can never ever be detected. And if it comes and collides with you, it is moving faster than a bullet, you know. Typical bullet speeds are only 2 to 3 meters per second, and this is moving at 7 to 10 meters or even faster than that per second. So even a paint flake can pierce you and then kill you. So any space activity that takes place must be secured from this debris, and we need to have regulations and methods by which space debris can be minimized. So we are working on this as a major topic, how to bring down in-house capability to observe and catalog and then observe it in such a manner that at least big debris are tracked properly. So we looked at this as various capability development, so I will not spend time on it. I will only say that we have created a center in ISRO for ISRO System for Safe and Sustained Operation Management. We call it IS for OM, where we created an observational capability using our satellite data and data sourced from various sources, and we do analytics over all these objects. 18,000 objects we study, and also smaller objects which are dead, and we study them and how they move around and how close they come to our satellites, how close they come to our activities, launches, etc. And then we give warning to the satellites so that you can at least move away so that it doesn't collide, create more debris. So this activity is a mathematical activity, it's an observational activity, primarily based on radars and satellites observations. So this is a great area which we have worked recently. And we would like to expand this capability by adding more observational network. We have currently a multi-object tracking radar called MOTR, which we developed indigenously using our own technology, which is a phased array radar that is kept at SRI, our launch station, and it can track objects, multiple objects of 10 centimeter size over a 400 kilometer distance. And we would like to expand this over many parts of the country so that we will be able to see not only the satellites but also our incoming objects that will be directed towards our nation. So we would like to create observational capability across the borders to secure our border as well as our airspace and space. So this is another major task that we are working on. We also look at observational capability as a strategic capability. See, recently we observed that many of our satellites in space, there are other people, friendly nations come and look at us very closely. We don't understand why they are coming and looking at our satellites so closely. Because from our radars we can see they move their satellites very close to our satellites, and they go around the satellites and they look at it more closely. And these are all not so welcome attitudes for anybody. So we need to keep a watch on our assets that we are putting in space, especially when our satellites increase. We need to look at intentional maneuvers of other satellites. We look at close proximity of other satellites so that our satellites are secured in times of need. Because space-based assets become a strategic asset, we need to find mechanism by which it can be secured and saved. And we created the mathematical and observational capability today to do this slowly, but it needs to have more investment and capability development in the coming days. Another important capability is the navigational capability, precision, timing, and position service. Possibly you heard about Navic, and your utility of Navic may be low today. And I want to tell you, we are assuring you that we will work on it to make sure that all of you will use Navic maybe a few years from now. And we have launched one of the Navic recently. Possibly you heard that Navic has been launched with a civilian L1 segment frequency, which is compatible for your mobile phones. So once we finish our 5 more satellites, which is destined to launch, and Navic will become available in all your mobile phones without any issue. And I am sure that you will prefer to use Navic over Google GPS because it is more accurate than GPS. It gives you a 3-meter accuracy or better accuracy than Google that can offer 20-meter plus accuracy. So because it is a geo-based system, it is not a moving satellite-based system, it's a stationary satellite-based system. So you will get a better accuracy. And we would like to make sure that this is available to the Indian community, and we would like to popularize it for both strategic users as well as civilian users. It has both the segments. It has a strategic segment with a high secure code as well as a civilian segment which is open to the public. And we are asking this question, if it has to ever become global, how it should be, whether we should ever become global like GPS or we should remain as a regional navigation system like Navic. This is a fundamental question we need to address, and I am talking to all the users and the government to say, yes, let us go to global. We need to invest certain money to create additional satellites to create a global constellation. If the nation desires to do a global constellation for our security, we must be ready to do that. I think this is something that we are working on. I want to tell you one of the important technology for this is called atomic clock. Atomic clock is a clock which is one of the highest precision clock. And all the clocks to the world today used in navigation satellites are manufactured only by 1 or 2 institutions of the world. One is in US, another in Europe, and third in some other nation. And this is purchased by us and used in our satellites. So again, like the traveling wave to amplifier, this became a constraint for us to build navigation satellites. So we developed a new clock of our own. It took almost 10 years to develop this clock. And in the last satellite, we have launched one of the atomic clock. And this clock is on board in our satellites today, which is developed in our satellite center, application center at Ahmedabad. And I want to tell you, this clock is working beautifully today than the importer clocks. And we would like to convert all our future satellites using our atomic clocks designed and built in India. And we also want to make sure that Navic is actually popularized in civilian segment. It's already there in civilian segment. Possibly you do not know. It is there in the vehicle tracking activity. We are Navic-based fishermen tracking messaging services we are already launched, and we are going to launch another 1 lakh terminals with the state governments. We are also into coastal security, train monitoring. We are also the national time service provider of the entire nation today. Entire time service, that is timing, the national timing is distributed through Navic network only today, even for your train services or for stock market timing, for everything. Navic timing is the current standard of timing. We have linked with Aadhaar for Aadhaar authentication, positioning service, etc. So there are a lot of civilian services already launched using Navic, but it has to be more popularized. We are working on new capability. This is specifically targeting the strategic sector. We understood, I told you, our observational capability is limited, just 24 satellites. We are planning to launch additional 50 more satellites specifically for strategic users. And this is one of the goals, and we are working on it to create critical area observations for our nation, and also maritime observations, high resolution observations, and radar-based observations. So multiple satellites have been now engineered and configured, and we are seeking the approval for launching them in due course of time. And we see that the growth of the satellite capability, the communication satellite capability, or ground station capability will be progressively expanded in the coming 5 years of time to help the strategic sector on a top priority manner. So these are the satellites which are already serving the strategic sector. GSAT 7, 7A, 6, and 6R are currently in service to meet the purely strategic needs. And we are building next generation of communication satellite to meet the strategic segment as well. And currently, I heard I got an approval to use GSAT 32 user from one of the strategic users recently. So we are very happy to build and launch them to meet the need of the communication services needs of the strategic sectors, especially on remote areas and oceans. We also look at maritime domain awareness as an important issue. We work with other agencies of the world to create this capability. But we say that it is very important to have this capability ourselves. And one of the satellite constellations we are looking at is to create maritime domain capability into the details. So I won't spend more discussion on it at this moment. So this is summary of whatever I told in terms of the communication satellites capability. So the pictures are already enough to communicate that we are building next series of communication satellites for strategic users, targeting them alone, not the civilian users. We also have messaging service networks, which is again important for various users. I think this is again to be expanded. We realize that many of the users today needs this capability, and we are porting the capability currently available in GSAT-6, which is an operating satellite, to another satellite, which is GSAT-32, which has a higher data rate capability for voice communication. So let me summarize my talk. I think I have covered a lot of areas. I went through very, very fast. Maybe I didn't dwell much on the pictures, because the whole message I wanted to give was more important than the specific pictures. So what I told is that over the last many years, we have been working on the technology capability in space sector in various ways, keeping the indigenous content of our rockets and satellites to be very high. Look at where are the things where people can block us. That area you create an additional capability. We scale up this through the participation industries over a period of time. Otherwise, we will not be able to provide the number of required services by government funding alone. We have to look at it in a business sense so that people will be able to make a profit out of it. We should work on technologies which will be world class, so that we can always remain at the edge. So in summary, I would like to look at rocket building continues to remain as one of the core competence of the space segment, and we should nurture it in various segments like the conventional rockets, low-cost rockets, air-breathing rockets, reusable rockets. We should also look at spacecrafts building new technologies like the electric propulsion, software-defined radios, optical communication, and various other capabilities, quantum, etc., into the regime, and continue to build it. And we should also look at low-cost constellation, materials development, functional materials and advanced material development, and look at disruptive technologies, which I have mentioned quickly, I didn't dwell on it at this moment because that's not the purpose of the talk. So all of this will continue to work on a rigorous scale to bring that capability and sustain the capability that we have already developed in the last 60 years. So in summary, let me tell you that if you look at the Atmanirbhar Bharat, their space roadmap for Amrit Kal, I can segment it into 5 different areas. The strategic area, innovation, exploration, continued human space, flight capability, reducing launch cost, and creating business ecosystem. So these are all important. If you simply look at government-funded space activity, it will not grow beyond a point. So we understood the business of space travel and business of space is important to nurture and keep the scale of activity high enough to create the support system for strategic users as well. And very important capability is a launch cost reduction. You are seeing it in US. The SpaceX is doing it at much lower cost than anybody else. And it is capable of launching thousands of satellites today. In the past, let's just imagine 5 years back, nobody was able to launch thousands of satellites in 1 year. Today it is happening because there is a reusable rocket available. So, and access to space is very low cost today. Earlier when people send man to moon, in America spent almost 1/3 of its GDP on that project. Today, America can send a man to moon at substantially low cost. And you will wonder how this low cost reduction occurred. Possibly you may not be aware. But today, per kilogram launch cost is only 1/10 or even lower than that was in the past, in the 60s or 70s. So it has really happened. And we must make technology improvements to make launch cost reduction possible through reusability, low in material usage, and technologies which will bring about that cost reduction. Human spaceflight is very, very important, and we have got a clearance to launch only Gaganyaan, but sustained human presence in space is very essential. We should also create manned mission capability and remaining in space like the space station capability over a period of time. And continue to innovate on spacecrafts, technologies, etc. And while we do all of this, the upper level is the strategic level. And all of these are adding a capability, strategic element of it. Today, all of you know that strategic element doesn't mean that it is only for certain segment of the people. Entire civilian infrastructure, including roads, ships, ports, your civilian traffic movement, everything is strategic. When you come to a conflict situation, or even when you talk about the commercial strength of a nation over others, everything becomes strategic. And we need to look at space as a strategic asset of the nation, and we should create that capability to sustain it, build it in an Atmanirbhar way. It's so important. And we have created a roadmap on how to build it. I am not presenting the details of the charts. To at a higher level, this is what we would like to see when India reaches 2047 and celebrates its 100th year of independence. We would like to see India as a very leading spacefaring nation. Thank you so much.
Good evening, ladies and gentlemen. Really a mesmerizing talk, sir. We are grateful to you for sparing your valuable time and being with us, accepting our request. Despite your busy schedule, I know you got back from abroad day before yesterday only, sir, and made it to this place to deliver this talk. Very, very, very encouraging talk. I am sure all of us are going to go home much richer on this field. I know, sir, you've grown with the organization when I have read your profile. Like for us, Air Force people, as aviation flows in our blood, it's space which is flowing in blood. And it was evident from your talk. I am sure all of you would have enjoyed that. We are grateful to you, sir, for updating us on Gaganyaan as well as Chandrayaan. And it was very encouraging to know when you made a statement that in certain fields, 95% contribution is from India and it's only 5% which is from abroad. We've really made big strides, though we know there are still miles and miles and miles more to go. But we have no doubts that with our focus on this, days are not far when we'll also grow from 24 satellites to 240, which is your vision. I'm sure we are going to achieve it. And as you said that out of 14,000 which are there in the space and 80% are not working, I'm sure all 24 of us are working, sir. And another factor which you touched upon was risk factor and the rate of return, ROI. These are, of course, matters of the past, which had been bugging us, of course, fear of failure, but we have gone past that now. And we've all seen it in the years, the way it has grown, sir. Thank you very much, sir. We are really very, very, very grateful to you. I take this opportunity to thank Air Chief Marshal V.R. Chaudhary, sir, Chief of the Air Staff, for sparing his valuable time and being with us, and the former chiefs for being with us despite having attended a lecture in the morning, making it to the lecture in the evening. The respected ladies, Shri Robilal, sir, and Madam, for being with us, all the serving air warriors as well as the veterans, and Secretary of IESL, who's made it to attend Indian Ex-Servicemen League on our request. He is also here with us. We are grateful to all of you. In my Thanksgiving, I will fail in my duties if I don't thank the AOA. So this show is your show, sir. We are just conducting it. All the admin arrangements for this function have been provided by AOA through AFND, through the auditorium, and the proof is in the pudding when we meet over a cup of tea subsequently in the foyer. Before I close my thank you address, we will like to present you a small memento as a mark of our remembrance of this small association with you. May I request President Air Force Association to give this memento to Shri Somnath. So we have a group photograph. May I request Chief of the Air Staff to please join us for the photo. Ladies and gentlemen, please join us for a cup of tea in the fire. Thank you very much.